Hi friends, welcome to GMK tutorials. In this video, we are going to see about the multi-stage amplifiers. Okay. So before starting this video, I have a small request for all of you. So please subscribe our channel for latest videos. So views ఎక్కువ ఉన్నాయి అందరూ ఛానల్ చూస్తున్నారు కానీ లైక్ చేయండి. సో మీరు లైక్ చేస్తే కొంచెం నాకు ఎంకరేజ్మెంట్ గా ఉంటుంది కాబట్టి సో లైక్ చేయండి. ఓకే, ఇన్ కేస్ ఇఫ్ యూ హ్యావ్ ఎనీ కామెంట్స్ రిలేటెడ్ టు ది వీడియో యూ కెన్ పోస్ట్ ఆన్ ది కామెంట్ సెక్షన్. So please remember one point, these videos are dedicated for examination point of view because of the last minute so many requests coming from the viewers point of view. Just I will take the initiation for this subject. Okay, so try to understand. In case is there any inconvenience in the videos, there may be chances due to some technical issues also you are also facing some issues. I accept that one. Okay, so thank you guys anyway thank you for your support. Okay, let's move on to the topic. So today topic is nothing but multi-stage amplifier. Okay, that is the analog electronic series point of view. Okay, that is the first one. So first of all, what is meant by cascading? Okay, multi-stage, the name itself represents multi-stage. The name lo multi-stage means that multiple stages. So ela undala multiple stages. So that multiple stages are connected in a cascading. So what is the meaning of cascading? So cascading is also called as a series, right? We can also call it cascading is nothing but series also. So that is why, so let us define this one. So cascading, first of cascading. So the cascading means that it is a process of, okay, it is a process of connecting the output of one amplifier as input to the another amplifier. Just I will repeat. So cascading means that process of connecting the output of the first amplifier as an input to the next amplifier, that is generally called a cascading. We can also call it a multi-stage amplifier. Okay, that's why I can simply write this one. The output of amplifier 1 is acts as input of amplifier 2. So that is nothing but simply called as a cascading. So for that purpose I will consider this is a amplifier block diagram. Just this one. So third one like this. Suppose if you are representing, so I will call A1 amplifier 1, A2, AN like this. Suppose if you are going for generalization. So first amplifier having a input Vi, so last one is also having a output. So this is generally called the multi-stage. This is generally called a multi-stage amplifier. Okay, so obviously there is a question mark, sir. What is the use of this one? Why we are connecting multi amplifiers in a cascading point of view? Is there any special kind of the usage means? Or obviously without any use of the connection of the series connection of the amplifiers, we don't require any kind of the configurations like this. So for that purpose, basically we have two types of requirements for this one. So that is nothing but first one is nothing but to increase the amplification or gain. Suppose to increase the gain. So that is the first reason. And second reason is nothing but to achieve the desired value of input and output resistance. To achieve the desired value. So the desired values of input and output resistances. I think నేను నీట్గా రాస్తున్నాను. ఓకే, నోట్ చేసుకోండి. ఓకేనా, ఇన్పుట్ అండ్ అవుట్పుట్ రెసిస్టెన్స్. సో దీస్ ఆర్ ది టూ బేసిక్ రీజన్స్ ఫర్ యూసేజ్ ఆఫ్ క్యాస్కేడింగ్. ఓకే, cascading. So ఎందుకంటే మనం ఒక యాంప్లిఫైర్ యూజ్ చేసి మనకి మాక్సిమం గెయిన్ అటైన్ చేయలేం. సో ఫర్ దట్ పర్పస్ ఆబ్వియస్లీ వీ నీడ్ టు కనెక్ట్ యాంప్లిఫైర్స్ ఇన్ సిరీస్. సపోజ్ ఫస్ట్ యాంప్లిఫైర్ కనెక్ట్ చేస్తాం, గెయిన్ 10 ఉంటుంది. సెకండ్ యాంప్లిఫైర్ గెయిన్ 10 times మల్టిప్లై చేసి ఇట్ బికమ్స్ as 100, రైట్? సో విత్ ఇన్ ఏ సింగిల్ యాంప్లిఫైర్ it is not possible to achieve that much of higher gain. So for that purpose we need to cascade the amplifiers in a cascading format to attain our maximum gain also. That is the reason one. Second thing is nothing but to achieve the desired values of input and output. Sir, what is the use of this input and output resistance? Means, sir, basically based on these input and output resistance only, we can perform lot of operations. That means, like if you go for input resistance, must be high for some cases. Maybe there may be cases, some values may be there. Output resistance must be low. So such a kind of the applications is also achieved with the help of a multi-stage only. Okay. So that is the second reason. So third one is nothing but due to this one, there is some effect is here. That effect is generally called as a loading effect. Okay, one more point is here, loading effect. So obviously there is a question, what is meant by loading effect? Right, I will come to there. Okay. So just we will take a one diagram for this one. Just this is the amplifier 1. This is the amplifier 2. So this is also having some inputs. So for that purpose, the amplifier can be represented as A1, gain of the first amplifier. Second one can be represented as A2. At the same time, obviously an amplifier having the input Vi, one input, and V0 is the output. At the same time, the first amplifier having some load resistance, I will call this one is equal to RL1. Okay, RL1 for notation. So at the same time, this second resistance is also having, second amplifier also having some resistance. This resistance is generally called the input resistance. So for notation point of view, RI2 is the, it's not equal, RI2 is the input resistance, RI2 dash is the input resistance of the second amplifier, right? Now what is meant by loading effect? So here the loading effect is nothing but when A1 amplifier and the A2 amplifier connected in a cascaded, the effective load of the A1, that means the effective load of A1, okay, effective load of A1 can be obtained by considering the effective load of the input resistance or maybe effective input resistance of the second amplifier. That is generally called the loading effect. So how you are going to design, how you are consider this a loading effect means that suppose the RL dash, that is nothing but first amplifier is RL dash, RL dash is equal to, that is a parallel value RL1 is parallel to RI2 dash. So this is the effective load of A1. This is nothing but effective load of A1 can be obtained by considering the effective input resistance of the A2 amplifier. Therefore, the effective load of RL dash new value is equal to the parallel, the total resistance of the corresponding two parallel resistance that gives rise to the effective resistance or RL dash of the corresponding amplifier. Now from this, if RI2 dash is smaller, suppose if RI2 dash, sorry guys, suppose if RI2 dash is smaller, if RI2 dash is smaller than RL1 dash, if RI2 is a smaller than RL1 dash, due to this voltage gain of A1 is decreases, due to which voltage gain of A1 is decreases. This is generally called as a loading effect. Decreases, this is generally called as a loading effect. This is generally called as a loading effect. Loading effect means the effective resistance, load resistance RL dash value is RL dash is greater than RI2 dash, then we can call as a loading effect. RI2 dash is a smaller than that of the RL1 dash, we can due to which voltage gain is decreases. That is generally called as a loading effect. At the same time, if suppose If the Ri2 dash is very larger, okay, second case, if suppose Ri2 dash is larger than RL1 dash, we don't have any loading effect. Okay, we don't have loading effect. That amplifiers are generally called as non-interacting amplifier. No loading effect. That amplifiers are generally called as non-interacting amplifiers. Non-interacting amplifiers. So in the first case, that amplifiers are generally called as interacting amplifiers. So this is nothing but interacting amplifiers. These are the two important considerations for multi-stage. So if the amplifiers having a high input resistance are called as a cascading loading effect does not take place. Therefore, such amplifiers are called as a non-interacting amplifier. In case input resistance value is very smaller than that of the RL1 dash, we can call as a loading effect. So based on this, the multi-stage amplifiers can be considered as a two types. That is nothing but multi-stage amplifier. Multi-stage amplifiers can be broadly classified into two categories based on this one. That is nothing but first one is interacting amplifier. Second one is nothing but non-interacting amplifiers. So the example for this one, first case is nothing but example for this is nothing CE and or CB configurations. CE and CB configuration. Second case is nothing but cascade of CS amplifier. These are the two examples for interacting amplifier and non-interacting amplifier. So in case of the multi-stage amplifier, there is a certain procedure to find out to analyze the multi-stage amplifier. So the first one is nothing but procedure, that is nothing but a procedure for multi-stage amplifier. So the first one is nothing but identify the transistor configuration. Just I will simply write this one. Identify the transistor configuration. Okay, now second one is nothing but draw the medium frequency analysis. And third one is nothing but analyze each stage. And fourth one is nothing, perform the overall analysis of the following way. So perform the overall analysis. So this is just a basic procedure, right? Just I don't want to take much time. So for that purpose, I can roughly mention these. So in that you have to take some important formulas for this one. So in this case, just you have to find out the four values. One is nothing but overall input resistance. First one is nothing but overall input resistance. This is very important. Overall input resistance. How we are calculating overall input resistance? Ri dash. Overall input resistance. The new value can be represented Ri dash is equal to Ri dash of the first amplifier. So that is nothing but Ri dash of first amplifier. So first amplifier input resistance is equal to overall input resistance. At the same time, secondary is nothing but overall output resistance. Overall output resistance R naught dash is equal to R naught dash of the last amplifier. So the last value ఏదైతే ఉంటుందో దాని యొక్క అవుట్పుట్ రెసిస్టెన్స్ ని మనం ఓవరాల్ ఆఫ్ లాస్ట్ amplifier. So third one is nothing but overall gain of the voltage gain. Overall voltage gain, overall voltage gain, just a shortcut. So this one is nothing but AV1 into AV2 into and so on AVN. That is the process, right? And fourth one, current gain is equal to overall current gain is equal to AI is equal to overall current gain is equal to, how we are calculating this one? So that is nothing but AV, current gain, AV into voltage gain into R, okay, RI1 into RLN dash, RI1 by RN dash, RLN dash. So RL, load resistance of the nth stage. So that is equal to AV is equal to AI into RLN dash by RI1. This is nothing but RI1, guys. RI1. RI1. This is nothing but RI1. So that is nothing but process of multi-stage amplifier configuration point of view. Okay. So this is a problem. In this problem, they mentioned that find the AV and AI, RI and R0 of a multi-stage amplifier for given circuit diagram. Okay. So apart from this, they mentioned some of the values, that is nothing but HFE. HFE is equal to 50. At the same time, HIE is equal to 2K. And HOE is equal to 20. Okay. Micro. Okay. So this is a representation. Suppose if you want to find out these kind of the problem, just I don't want to go for the complete calculation, guys. Just I have to give the basic idea for solving the problem point of view. So in this case, what we have to do is, first of all, you have to identify what is the configuration. That is the 4 steps point of, right? In this case, first is nothing but we have to follow the 4 procedures, right? First, identify the transistor configuration. So in this case, the type of the transistor is a CE configuration. So that is very important. So the configuration is CE configuration, right? So one is nothing but with the bypass capacitor. Second, so this is nothing but without bypassing. This is nothing but with bypassing capacitor. That is also one more. So CE one is nothing but first stage without bypass capacitor. Just I will represent CE2 stage is equal to with bypass capacitor. That is nothing but just a representation. So third one is nothing but we need to represent the medium frequency analysis. So in case of the medium frequency analysis, nothing but simply you have to short the capacitor values and the supply voltages to ground. Then you can represent the circuit diagram that is equivalent to the equivalent circuit. AC equivalent circuit, also called the small signal model of the corresponding transistor. So for that purpose, just I have to draw the complete diagram. So for this purpose, this transistor one is there. At the same time, for this transistor, some resistance is also there. So here the capacity is short circuited. Okay, therefore you will find one resistance, that is nothing but RB is also connected like this. Some input resistance is also there. At the same time, input value. This is the phase 1. At the same time here, this is nothing but voltage divider rule, right? So this is nothing but all are connected to one point. So this at the same time, this RC value is also connected to the ground, right? So I will replace with this is also connected to the ground. At the same time, supply voltage is also connected. Therefore, I will represent like this. So this is the one resistance. Second resistance is also connected like this. Output resistance is also like this. This is the one part. At the same time, second part is nothing but obviously capacitor is there in between. So let us see here. This is very important. So up to now, just I have to draw the. So in this case, this is a short circuit. Okay, these two, this is also connected to the ground, this is also connected, so these two are connected in a parallel configuration. So for that purpose I can mention that with some single resistance, so this resistance only. Okay, at the same time the second one is nothing but CE resistance, so this is also as usual representation. So here at the same time some output resistance, that is also called as a 5 kilo ohm resistance. Okay, that is also connected in the output side. Okay, that is very clear, right? So coming to the second stage, it is also same scenario. So this is also capacitor short circuited. Okay, these two are connected in a parallel configuration, therefore these two are grounded, therefore at that time these two becomes a parallel configuration. It is also short circuited, it is connected to the ground, so one emitter resistance, one resistance. So overall we will get like this. So that is nothing but just I will represent the complete analysis. So the second part is also same thing, so it is also having some input resistance. So for that purpose I will connect input like this. So at the same time transistor having some emitter resistance, at the same time output resistance, some load resistance output. So this is a configuration for equivalent model for this one. So in this case just I have to mention this one, this is a 1 kilo ohm resistance as I said earlier in the first case. Note down the circuit first before analysis. This is the supply voltage. So this we will call as a RB1, just for notation point of I will call RB1. So this is nothing but 0.27. How you are getting 0.27K? So 0.27K is nothing but emitter resistance. Okay, this is nothing but a emitter resistance. Actually 27 ohm, right? So this can be represented 0.27K. So that is the one notation. At the same time 5 kilo ohm resistance is obviously there, so that is the output side. Just if you are taking like this, at the same time this is the input resistance for 27. At the same time RB2 is nothing but obviously as I said earlier, the RB1 and RB2 is nothing but resultant values of this one. Okay, it is not a direct value, it's resultant values. So resultant is the voltage divider resistance can be connected in a parallel configuration. That resultant value can be represented RB2 as well as RB1 also. So as I said earlier, this is also same emitter resistance that can be given in the problem itself only. Maybe I think it is nothing but 1 kilo ohm resistance like this. Okay. At the same time, obviously in this configuration, just it becomes as a short circuit. Instead of R2, it connected as a, why? Because for this one, beside there is some capacity there. So that capacity is obviously short circuit, means that the maximum current is flowing in that direction only. Therefore, this resistance is replaced with only short circuited path. So we don't have any emitter resistance, just to represent with the short circuit directly. Why? Because it is a bypass capacity is there, so therefore it acts as a short circuit for this one. So second last one is nothing but load resistance. So for that purpose just I have to mention the values. This is nothing but actually 5 kilo ohms. Just I don't want to go for the mathematical level, just I will give the brief idea only. Okay, na? So this is nothing but RL dash, like RL2 dash. So RL1, RL2 dash. Okay. So here RB1 is nothing but RB1 value is equal to, what is the value? RB1 is equal to, so in the first circuit diagram there is a parallel configuration, the 47 and 33 parallel value. So that is nothing but 47 parallel with 33K. So that gives rise to 19.38K around. Okay. Just you will go through the calculation. I don't want to go for the complete calculation part. Just the second one, RB2 is equal to the second part voltage divider. That is nothing but second part voltage divider value is nothing but 56 and 27K. So that parallel value gives rise to RB2. Therefore 57 parallel with 27K. So you will calculate some value, you will get 18.2 around. At the same time, RL2 dash is equal to so last one, RL2 dash is equal to, that is nothing but equivalent resistance of the collector transistor, that is nothing but 4K is parallel with, because of 4K is also connected to the ground, at the same time 5K is also connected to the ground. Therefore those two are connected to the common point. Therefore the resultant of 4K with 5K, that gives rise to the RL2 dash. So those are the values for this one. Now we need to find out the different values, right? That is nothing but so RL2 dash is equal, you will get around 2.2k. Suppose if I calculate this one, 2.2k. This is the value for this one. Now we have to find out the voltage gain, right? So AV2 is equal to, there is a formula there. Just I will represent only formulas. AV2 is equal to minus HFE. So obviously HFE is nothing but minus HFE is due to the current opposite side. Minus HFE into RL2 dash by HIE. Already in the given problem, HIE is also there, HFE is also there, RL2 is already calculated just now. Okay, with the help of you will calculate the AV2. So that is the one thing. At the same time, RI2 is also equal to input resistance. Okay, RI2 is also equal to HIE. Therefore, that is equal to 2 kilo ohms only. That is the one more information. At the same time, RI2 dash is equal to, overall resultant value is equal, RI2 dash is equal to RI2 actual value is parallel with RB2. RI2 is parallel with RB2 is nothing but a resultant value of input resistance. Suppose if you are calculating these two, RI2 is nothing but 2 kilo ohm. Therefore, 2 kilo ohm is parallelly connected with resultant value of RB2. RB2 value is approximately 18.2. Then you will get a value of around 1.80 kilo ohms, like this. At the same time, you will find out the output resistance. RO2 is equal to, actually they given that RO2 is equal to 1 by HOE. So given problem itself, there is 1 by 20 10 power minus 6. Okay, that value gives rise to 50 kilo ohms. So from this you need to calculate RO2 dash, output value. Okay, output value dash is equal to RO2 is parallel with output resistance, that is nothing but RL2 or RY2. So that is equal to 4 kilo ohm resistance. 4 kilo ohm, that is nothing but R. So that is nothing but parallel resistance of that value, right? So that is equal to Rx and Ry quantities. So if I am taking that one, Ry2, that is equal to 50 into 40k. 50 into 40k. Then you will get the value of 3.7k. 3.7k. So that is nothing but Ri2 and RO2 resistance values. So at the same time, if you want to find out the load resistance, there is some procedure again, right? So load resistance RL dash is equal to load resistance RL1 parallel with RI2 dash input side. So RL1, that means input first amplified load resistance is equal to actual load value, load resistance value into input resistance of the second value. You will get RL1 dash. At the same time, AV1 is equal to voltage gain of the first one is equal to minus HFE into RL1 dash. That means load resistance of the first one resultant value by HIE value, obviously in the given problem HIE into 1 plus HFE into RE. Okay, then you will get the value of AV1. At the same time, RI1 is equal to input resistance of RI1 is equal to, what is the value? HIE plus 1 plus HFE into RE. Sorry, that is nothing but second value. At the same time, RI1 dash is equal to that is the RI value is parallel with RX1. RX1 is nothing but the resistance that is connected to the like RB1. Okay, so that is nothing but RB1. Okay. So therefore you will get the resultant value of, that is nothing but input resistance. You will get RX1, that is nothing but 19.8 as per calculation. Just you will get 8.69 kilo ohms. So this is a process for calculating the input resistance overall analysis, input resistance Ri dash, output resistance R0 dash, voltage gain AV, and current gain. So we need these all values, right? So from this, if you want to find out the overall analysis for this problem, is nothing but, so Ri dash, obviously you know that Ri dash is equal to last value is nothing but R input dash. So that is nothing but around 8.69K in terms of kilowatt. At the same time, R0 dash is equal to R2 dash, that is equal to 3.7K. Right, these two values are very clear. At the same time, voltage gain is equal to actually multi-stage, right? So AV1 into AV2, that is the product of those two. That is nothing but you will get minus 4.18 into minus 55.5. Then you will get the value of something 239, 231.9. You will get around like this. At the same time, AVS, voltage current gain is equal to current gain AI is equal to AV into RI1 divided by, this is a formula actually, RI1 into RLN dash. Okay, so these are all values are known terms to you, so you will calculate the AI value also. At the same time AVS is equal to, okay, so in case if you want to find out the AVS is also equal to AV into RI dash into RS plus RI dash. So by using the source resistance values, so you will get, so this is a way of calculating the corresponding multi-stage amplifier. Suppose in case if you go for the MOSFET's point of view, they will mention the same kind of the circuit, whether it may be CE configuration, in case of the common source configuration. So for that purpose you have to identify the type of the source amplifier, whether it may be common source or common drain configuration. After that you have to replace the small signal model, or we can also call it a medium AC equivalent circuit. That is nothing but just so you will connect the supply voltage to the ground and connect the capacitor to the short circuit. Like that you will get the same analysis whatever we did in case of the BJT one. So at the same time you will follow some kind of the process like whatever we discussed in the previous case, just there will be small changes in the formulas based. In case of the BJT point of view, minus HFE into RL dash divided by HIE into 1 plus HFE into RE dash. So but if you go for the, in case of the MOSFET point of view, there is a small variation, some formulas will be varying. Based on that one you will calculate the process for this one. Okay, so I hope it is just a basic video for this one, multi-stage amplifier. Okay, thank you guys, thank you for supporting this one.